All right, guys, welcome to our Unit 2 Quiz 1 study guide. Once again, as always, I'll be going through the even problems. That's what you're required to do. And then odds are included with answers in case you want a little extra practice. Begin. All right, so for number 2 here, the first thing we want to do is we want to rewrite this one and this one. We don't like them written like that. So the 6x squared is fine. But I'm going to change that 7 fifth root of x squared into 7x to the 2/5. The bottom I'll just keep as 5. And then minus. As for this guy here, I'm going to be moving the x squared up to the top by the 5. And when I do so, I'll make its power a negative. So that's the first thing we want to do before we apply the power rules. We want to make everything's written as a power. The next thing we're going to do is we're going to actually do the integration. To do integration using the power rule, you add 1 to your power. So that's going to become 3 now. And then we divide by that number. Continue that process. So for this one, if I add 1 to it, the shortcut would be just to add the top and the bottom number together. So 2 plus 5 is 7. And so that's going to give me 7. And we keep the bottom the same, fifths. So if you add 1 to 2/5, you end up with 7/5. Okay. Now we have 7 over 5 here still, right, from the original problem. But what we would typically want to do at this point is divide by this number, right? So I want to divide by 7/5, which means we would want to put it down here. But actually, we talked about how it's not preferable to divide by a fraction. Instead, it's better to multiply by its reciprocal. So I'm going to multiply by 5 over 7 instead. Now, it's important you understand it's the reciprocal of the power and not these numbers necessarily. In this case, it doesn't matter because they're the same, but understand we're taking the reciprocal of the power when we do that. All right, next one, we're going to add 1 to that power. Got to be careful with negatives. If you do that, you get -1. And then, of course, we divide by that value. And now we're ready to start simplifying it. Let's not forget our plus c, though. So 3 goes into 6 twice, so that becomes 2x to the 3rd. In this case, both of these cancel. So I'm left with x to the 7/5 power there. This negative is going to cancel that negative to make a positive. And then the 5 is going to stay in the numerator. But since that x to the -1 is in the, since that x in the top there has a negative exponent, I'm going to move it to the bottom with a power of 1 that's positive. And since it's a positive 1, I'll just leave it as x instead of x to the y. And then we don't want to forget our plus c. So there is our final answer for number 2. Let's go ahead and move on to number 4. So this one's asking us to find the general solution. And basically what that means is we just need to integrate both sides. When you integrate a derivative, you just get the antiderivative. So the integral of y prime is just y, right? And we're going to integrate this side also with respect to x. So there we go. All right, and we just get to do that power rule again now. So here we go. If I add 1 to the power, I get x squared, and then I divide by that new power. And since this is a constant, when you have that, you just put an x next to it, and we don't forget our plus c. All right, so these cancel out, and I'm left with x squared plus x plus c, and that's what we call the general solution. Go ahead and move on to number 6. This one is asking for a particular solution. The way that you do these ones is very similar to the last problem. So the first step is to integrate both sides once again. So integrating this side, we just get y. And integrating this side, let's see what we get. We're going to get 4x squared over 2 plus 3x plus c. And then we can go ahead and simplify that a little bit to get 2x squared plus 3x plus c. And that's my general solution, but we want a particular solution. And what that means is we're going to find out what the c value is. And you do that by plugging the numbers in that they give you here. So this number here, the -1, that's an x value. and the output here is my y value. So I'm going to be plugging a positive 1 in for the y value, and I'm going to be plugging a negative 1 value in for x. And then I'm going to solve for c. And I end up with c equals 2 by solving that equation. The final thing I'm going to do is I'm going to rewrite my general solution, but this time I'm going to do it without the c. And instead, I'm going to put what I got for c. The c value that I solved for was 2, so that's what I'll put right there. And that's what we call a particular solution. So a particular solution is when you find the c value of the general solution by plugging in your point, which is called an initial condition. All right, let's move on to number 8. Notice we have some numbers here on number 8. It's called a definite integral. And to solve these, we're going to use the first fundamental theorem of calculus. And according to the first fundamental theorem of calculus, the first thing we're going to do is we're going to integrate this expression here. So here we go. Now you don't need a plus c when you're doing definite integrals, so I'm just going to leave that off. And whenever you're doing definite integrals, we just put brackets there, and we move the limits of integration, which are -3 and 1 to the right side like that. The next thing that we're going to do is we're going to plug in the 1 and the -3 with a minus in between each of those expressions. So if I plug in 1, it would look like this. And then if I plugged in -3, it would look like this. Now the order in which you plug these things in matters. The one that's on top has to come first, and the one that's on the bottom has to come last. All right, so as we talked about in this lesson, when you're doing these types of problems, you want to have brackets, right, with a minus in between them. And then you also want to set up your problems with parentheses, and then you just plug the numbers in, okay? After that, you go ahead and just follow through with your order of operations. So 1 squared is 1, and 1 times 2 is 2, divided by 2 is 1. So I end up with the following. 1, and then we have plus 1 still. Here we have -3 squared, that's 9, and 9 times 2 is 18, divided by 2 is 9 again. All right, these two make 2. These two make 6. 2 minus 6 is -4. Okay? And that's how you do that one. So with definite integrals, you integrate first, and then you plug in your limits, subtract the values, and you're good to go. Take a look at number 10. All right, now as you guys can see on number 10, we have an inside function here with an integral. When that happens, that typically means we're going to do u substitution. So with u substitution, we set the u equal to the inside function first, and then we take the derivative of u with respect to the variable that's in the equation, which in this case is x, and that would give me 8x cubed. Now, let's go ahead and the next step is to get the dx by itself. So I'd multiply both sides by dx first. And then I would divide both sides by 8x cubed. And that leaves me with du over 8x cubed is equal to dx. Now we're ready for the u substitution. I'm going to replace this piece here with u because that's what u equals. And I'm going to replace the dx with du over 8x cubed because that's what dx equals. And at this point, we should be able to cancel out anything that has an x in it. You might have some numbers left over. Numbers are okay, but you shouldn't have x's at this point. And so I'm left with u to the fourth du. And now we're ready to go ahead and integrate like normal. So we're going to add 1 to the power and divide by that value. And we don't want to forget our plus c. Now the last thing we have to do is replace the u once again. The u is 2x to the fourth minus 5. So we're going to put that value back in place of the u now. And there you go. Now another way this answer can be written is like this, just so you know. Instead of being put over 5, you can write it as being multiplied by 1/5, which is the same thing. Either one of those, though, are acceptable final answers. All right, let's go ahead and take a look at the next one. Number 12. Now, number 12 is an example. No, actually, it's just more u substitution, actually. I see another inside function here. So u is equal to x squared plus 4. Step, find the derivative of u with respect to x. Next step, get the dx by itself. Next step, replace this with a u. Replace this with what it equals, which is that. Cancel anything out that you can. And at that point, you should only have u's. Now we're going to go ahead and rewrite this because, as you know, when we do integrals, we don't like radicals. We like powers instead. So I'm going to write that as u to the 1/3 power. And then we're going to integrate. So if you add 1 to this, you get 4/3. And instead of dividing by that number, I'm going to multiply by its reciprocal. And we don't want to forget our plus c. And the last thing we're going to do, of course, is we're going to replace the u with what u equals. And u equals x squared plus 4. And there you guys have it. So that's number 12. Let's go ahead and take a look at our next one. Just another u sub problem, just showing you guys a couple different types. So on this one, my inside function is the 2x squared plus 5. The derivative of that would be 4x. And getting the dx by itself would look like this. Next, we start plugging stuff in. I'll replace that with u. I'll replace that with this. And then we cancel. And I'm left with this more familiar looking expression here. Next, we're going to move that u up to the numerator. So it's u to the -3. Now we're ready to integrate, so I'm going to add 1 to that power, getting -2. And then I'm going to divide by that value. Don't forget your plus c. And I'm going to go ahead and move that u to the denominator. And when I do, that's going to leave nothing in the top, but technically there is something up there. There's a 1. So it's going to be u squared on the bottom now. It becomes positive when you move down there. Also notice this negative. You could just leave it on the bottom, but technically when you have a fraction, it's more normal just to leave it in front of the whole fraction. And then plus c. The last thing we're going to do is we're going to replace the u with what u equals, which was 2x squared plus 5. And there's that one. Alrighty. Now we get to do another u substitution, but this time it's a u substitution with limits on it. It's a definite integral. So my u value is, of course, x cubed minus 1. The derivative of u with respect to x is 3x squared. Getting dx by itself We get that. And going ahead and putting everything in there, we have the following. Now, before I move on to the next step, we have to understand that these limits are going to change also. The way that you do that is you plug these numbers into this equation for x. So, for instance, I'm going to replace x with 0, and that will tell me what my new top number is, which is -1. So instead of having 0 on the top, now it's going to become -1. We're going to repeat that process, so I'm going to plug the -1 into this equation now. And I get -2. And so now the bottom number, which was -1, now becomes -2. These are x values here, and whenever we do u substitution, we have to change everything into a u that's an x. And so that includes those limits. All right, so there's that. And you see we still have some x's left there, but that's okay because they're just going to cancel out. So now we have -2 here, -1 here, u squared du. All right, from there we're ready to go ahead and begin our integration. So if you integrate this, you're going to add 1 to the power and divide by that value. And when you do definite integration, you don't need a plus c. All right, the next thing I'm going to do is we're going to do our fundamental theorem of calculus. So we're going to have bracket minus bracket. And inside the brackets, we're going to have this, but with parentheses where the u was. And in the first set of parentheses, I'm going to plug in my top number, which is -1. In the second set, we're going to plug in the bottom number, which is -2. And then we just get to simplify it. Double negatives there become a positive. And then combining these together, we get 7/3. Final answer. All right. Now, number 18 is another u sub problem. Something interesting happens here. Let's begin and see what that is. So we set u equal to the inside function. We find the derivative. And then we get dx by itself. In this case, since it equals 1, that means du just equals dx. If you multiply both sides by dx, that's what you get. Now we're ready for our substitution. So we have 5x u cubed du. Now, what's interesting here is that the x won't cancel out. We're left over with an extra x. And when that happens, what we want to do is we want to take this equation here, u equals x plus 3, and what we want to do is get the x by itself instead of the u. So I'm going to move this 3 over here like that. And that means that x equals u minus 3. So I'm now going to, first of all, I like to put that u to the third in the front. And that 5 also, I like to put that up here in the front. But that x is going to get replaced now. I'm replacing the x with u minus 3. Okay? And then we're going to go ahead and distribute the 5u cubed into the inside. All right, and that's the end of the new stuff. The rest of it after that's pretty much the same. We're just going to integrate like normal. So we add 1 to the power and divide by that number. And we repeat again, add 1 to the power and divide by that number. We don't want to forget our plus c. And we're going to replace the u now with what u equals. Here the 5's cancel out. So I'm left with u to the 5th. And next one I have 15/4 times u to the 4th plus c. But instead of u, I'm going to put what u equals, and u equals x plus 3. And there it is, final answer. So whenever you have an x left over, even after you do u substitution, you go back to this equation, solve for x, and whatever you get for that, you plug that in for x. And at that point, you should have no more x's left in your equation. All right, one more thing to look at. All right, FRQ question. The height of a tree at time t is given by the differentiable function h, where h is measured in meters and t is measured in years, and the selected values of h are given in this table below. All right, so for part A, we're being asked to find the definite integral of h prime of t dt, and then we want to interpret the results. So we're going to find and interpret, and in our interpretation, we want to include the appropriate units. This is going to be a 3-point question. You get 1 point for doing this correctly, you get 1 point for the correct interpretation, and 1 point for the appropriate units. Okay, so it's a 3-pointer. So let's begin here. So first of all, when you integrate, let's start off by writing the problem again here, actually. Be a good way to start off. When you integrate h prime, you just get h, regular h, because regular h is the antiderivative of h prime. And then using the fundamental theorem of calculus, we could say, right, we have our function, plug in the 7, minus the function with the 3 plugged into it. And then from there, we could just use the chart, h of 7. So I need to find out where t equals 7 and find the h value that goes with it, and that means h of 7 is 11. Next, we have h of 3. So the h value that goes with it is 2, and therefore my final answer is 9. So that's 1 point, being able to get down to that answer there. Let's go ahead and move on to understanding what are our units for this. Well, this is an h value, and this is an h value. So basically, this is the height of the tree in year 7, and this is the height of the tree in year 3. So if I took its height in year 7 and subtracted from it its height in year 2, that tells me that the total height has changed by 9 meters. So the units are meters here. It's whatever the h units are. But we've also kind of started to understand what the interpretation is then. So basically, this tells us how much the tree has grown from year 3. I'm sorry, did I write that right? Yeah, I did. From year 3 to year 7. So from the 3rd year to the 7th year, this tree increased by 9 meters. Why did it increase? Because it's a positive value. So how would we write our answer out here? Here's how you'd write your interpretation. The height of the tree increased by 9 meters from year 3 to year 7. And that's our interpretation. Remember, interpretations have 3 parts to them. They have the output units, they have the input units, and they also have the context. In other words, what's happening in the story problem. All right? So that takes care of that. Let's go ahead and move on to part B. So for part B, it's a lot like part A, just a little bit more to it. So first of all, I would want to distribute, and it's not really distribution, but you can call it distribution. I'm going to distribute the integral to all these pieces. So this is going to be the integral of 5, 10, 4h prime minus integral 5 to 10 of 2t. Now, why is it minus? Well, it's minus because this is a negative 2t. And then the last one is plus the integral from 5 to 10 of 4 dt. So the first thing I'd like to see you guys write down on here on your FRQ is to distribute that integral to each piece. Okay. Now you could do this in this step already, but I just didn't want to do too many things at once. But this is a constant here, and so technically that constant can come out of the integral, just like that. Okay. You could do the same thing with this one, but I'm just going to leave that one. But there we are so far. So let's go ahead and keep going here. So if I were to integrate this piece, first of all, the integral of h prime, as we saw in the last problem, is just h. Our limits go over here, and that 4 is still out there. Next, let's integrate this one. If I add 1 to the power, I'll get 2, and if I divide by 2, it'll cancel this 2 out. And I'm just going to be left with t squared if I integrate that. And then the last one, if you integrate just a number, you just put a t next to that number. Now, why is it a t? Because that's what I'm integrating with respect to. All right. So that's the next step I'd want to see, is the integration of all those things. All right, and for this step, I would say that this is the first place where you're going to get a point, is where you integrate these and have this little setup going on right here. All right, so, but what comes next? Well, after that, we're going to do the fundamental theorem of calculus. So we're going to do each of these one at a time. So let's start off with this guy. All right, so we have 4 brackets minus 4 brackets and h parenthesis h parenthesis, and then we're going to plug these two numbers in, 10 and 5. Okay. Let's go ahead and finish this piece before we move on to the next two pieces. I think it'll get a little confusing if we try to do it all at once. So, all right, so what's h of 10? Well, at 10, h is 15. And at 5, h is 6. And so this is 60 minus 24, which comes out in the end to be 36. So let's go ahead and make some space here. So now I'm going to get rid of all that, and I'm going to replace it with, put that minus back. I'm going to replace everything that it's got with what my answer was. So that was 36. And now we're going to do the same thing with this t squared here. So we're going to have bracket minus bracket, t squared, and we plug in our 10 and our 5. 10 first, and then the 5. So that's 100 minus 25, which is going to give me 75. And that's what I'm going to put right here now. That whole thing equals 75. All right, and then we got one more to do here, 4t. So if that's already been integrated, never mind. So now we do our brackets. Replace the t with parentheses. 10 goes in first. 5 goes in last. That gives me 40 minus 20, which is 20. And then that's what I'm going to put right there. All right. Lastly, we're just going to put those three numbers together, and we'll be home free. And I think putting all those together, we get negative 19. And there you go. And so that's the end of it. All right, hopefully that was helpful, and we'll see you guys in class. Have a good one.